we may actually need to use the formula for calculating the sum of the geometric sequence. I can definitely just throw the formula directly to you, but I thought it might be worth for us to know exactly how to derive that formula, because I don't myself actually memorize that formula always. If I can remember, good, I can just apply it. But if I really forget about the formula and I don't have the actual formula at hand, in that case, I think deriving it within maybe a minute will be very beneficial. So that's why I want to show to you. I think it's very cool actually to really remember the derivation steps for this formula. Let's talk about it quickly. Okay. So we talk about geometric sequence, meaning that all the subsequent terms actually have some common factor compared with its previous term, right? Some common factor as opposed to some common increments in the case of the arithmetic sequence, right? So let's say we got some initial term I and also a common factor R, and also the number of terms will just be K, right? I try to choose the symbols so that it will correspond to our calculation for the total running time for the doubling strategy later. But anyway, of course, you can definitely replace I, R, and K by other symbols if you prefer. But let's now use these so you wouldn't get confused when we apply it later. So the sequence we have, the sum that we want to calculate is this. Let me say I want to calculate the sum of the first K terms of this series over here. So that will be basically equal to initial term will be I. The second term will be I multiplied by R, the common factor, plus the third term will be the second term times R, which will be I multiplied by I squared, right? And plus I R cubed, and all the way to over here. And if we say we actually got K terms, what exactly should be the final term? That's also very important for you to know how to derive that, right? Let me just help you a little bit over here. You can see I over here can be rewritten as I multiplied by R to the power of 0, which is 1, right? You can see for the very first term, and also let's think about which terms are we talking about. This is the first term, and this is the second term. This is the third term, and that's the fourth term. Right? And now we want to talk about the kth term. What should that be? Right? That's exactly what we want to know. And actually, we have done some similar reasoning, observing the pattern in the earlier part of the lecture, right? Where we analyzed the arithmetic sequence for the constant increment strategy. Similar. Okay. You can see for the first term, 1 over here is simply 0. And when we got 2 over here, the exponent over here is actually 1. When we got 3 over here, exponent is also 1 minus, right? And also 4 over here is also 1 minus, which is 3, right? So if you can observe this particular pattern over here, so this one over here, the last term will be I multiplied by R to the power of K minus 1, right? You can see we go from R to the power of 0 all the way to K minus 1. It's pretty much like an array, going from index 0 to index K minus 1. So the length of the array should be K. Alrighty. Right, that's the series I want to write down first. Right, sorry, let me put it here. Okay, let me put it back. Alright, so that will be the first one over here. And how do we know its sum? It's incredibly simple, but you just got to remember the critical step. The critical step is, let's now try to multiply the entire series by the constant factor once more. Alright, so what I meant was, what would be R multiplied by SK? Right? So that means we're going to multiply the whole thing by R. So every term is going to be multiplied by R. So you will see a lot of overlap between this series over here and this series over here. Right? And of course, I multiplied by R will be IR. So I'm going to put it over here just to show you the correspondence. You can see the first term for this series over here is the same as the second term over here. All right. And what about second term over here multiplied by R? So that will be plus I multiplied by I to the power of 2. Right. You can see the second term in this series over here is corresponding to the third term over here. Right. And similarly, let's say plus I to the power of R4, right? And then we say all the way to, right? And of course, you can think about what's going to be the previous term of this one here. That should be k minus 2. K minus 2 multiplied by r, it will become k minus 1, right? So that will be I multiplied by r to k minus 1. Plus, finally, this term over here multiplied by r is going to be I times r to the k, right? Let me just draw very quickly the correspondence just in case you still cannot see it, right? You can think about this over here multiplied by r, this part over here multiplied by r, and this one here multiplied by r, and etc., right? And the second last term over here multiplied by r, this one over here multiplied by r, over here. Multiplied by r, multiplied by r, multiplied by r. Alright, everything should be logical right over here, right? And we can see a big overlap over here. You can see this part here is exactly overlapping, which will be nice because we can somehow cancel them out, right? And now you got two choices. Either you can try to do sk minus r. You can do sk minus r times sk. Or you can do this minus this. You have choices. But in our case, our r is actually going to be larger than 1. So I would suggest we actually do this one minus this. But either way is okay, right? Let's now try to do that. So what we'll do is we're going to say r, well, actually, so let me make it a little bit thinner. So this one over here, subtract this one here, right? So we can factor out. So it's going to be r minus 1 times sk, right? I'm pretty sure you're okay with that. And we're going to, of course, cancel out this part over here. So that'll be this minus that. It's going to be I times rk minus I, right? Let's now factor out I times rk minus 1, right? So what does that mean? That means the original sum of the k terms that we want to calculate is actually going to be, right? If you actually try to look at that over here, this one over here is actually equal to this one over here, right? Just divided by, which we can simply divide this by r minus 1, right? Sk will be equal to initial term I multiplied by rk minus 1 divided by r minus 1. So this will be the ultimate formula, right? If you really find this formula very easy to remember, good for you. In that case, maybe you don't necessarily have to know exactly how it should be derived, but I would say if you're like me, my memory doesn't really serve me very well, especially for a long time sometimes. In that case, I would say if you just forget about the formula, and you can simply just try to remember the critical step about multiplying the series by r and try to cancel out the big overlap over here, and then you can derive the formula yourself. And of course, I'm trying to explain as I'm writing, so that's why it takes longer. But if I had to really derive this on a piece of paper, it took me about 1 minute to really get the formula. I think that would be much more efficient than simply trying to recall from your memory what the formula exactly should be. Alrighty. Assuming that you're okay with this formula over here, let's now move on to do our analysis for the doubling strategy.